Hello, COVID. I'm Serge, the most powerful scientist of all time. In my dream. So screw this ugly football picture. I got an artist to draw you, and here it is. So let's talk about the parts of COVID-19. So first, this is an RNA of a virus. An RNA is like a DNA. It contains instructions of how to create a new virus. These are the nucleoproteins, and they tell the virus what to do like RNA. And this is viral envelope, which works like cell membranes to protect it outside of a host cell. And the spikes outside here are spike proteins. They are like keys to your house, and they're like keys to trick the host cell to let them in. So you know how COVID-19 structures. Let's find out how they can infect our bodies. First, the microscopic virus enters through the nose or mouth, where it begins its infection of our airways. Second, the outer spike protein of the coronavirus latches onto specific receptors on the surface of cells in our respiratory tract. In the case of COVID-19, the virus latches onto the ACE2 receptor. Third, this binding triggers the passes of which the virus fuses into human cells. The viral envelope merges with the oily membrane of our own cells, allowing the virus to release its genetic material into the inside of the healthy cell. Fourth, the genetic blueprint of the virus is RNA, which acts as a molecule message, instructing your host cell machinery to read the template and translate it into proteins that make up new virus particles. Sixth, each infected cell may produce and release millions of copies of the virus, which can then go on to infect other neighboring cells, as well as neighboring people when they are expelled from the airways in droplets via coughing and sneezing. But how do our bodies protect our lung cells and attack the virus? I will show you now. Antibodies are Y-shaped proteins produced by our immune system after we are exposed to a disease-causing invader, such as bacteria or a virus. These proteins help the body remember the threat and to be better prepared for the next encounter. Antibodies to the novel coronavirus recognize the virus's outer spike protein, enabling them to bind to the surface of the virus, preventing the virus particles from attaching to the host cell.